Well, thank you so much. I'm very honored to be here to give a talk, and I'd like to share with you all our experience on developing hydrogen storage tank. And also, if I have time, I'd like to give a little bit of an introduction of our pipelines, since pipeline is also part of a hydrogen tank. Okay, again, my name is Song Gyu-ha. Ha is my last name. I'm from Hanyang University. My lab is called Hanyang Structures and Composite Lab. In short, I will call HSCL. And also, I'm a CEO of the 3P.com, which is the startup company in our Hanyang University. Okay, well, we, HSCL, collaborate with the global composite industry. Before I talk about the hydrogen tank, I would like to introduce our lab. We mainly innovate composites in 3 different areas: materials, design, and manufacturing. So when we design, we have to consider material and manufacturing all together. And first, as you know, the composite consists of resin and fibers. Now, next step is preform and applied to many different industrial applications. And so, again, materials and design and considering manufacturing process. Actually, I would like to introduce a partner which we are working together in material, resin part. Arkema is a French company produce the thermoplastic material. We've been working together with Arkema for the last 10 years. And Aditya Bora is an Indian company which produces recyclable epoxy resin. And also Swanco is a Taiwan company that recently developed recyclable epoxy resin. And Kase is the Chinese company, very famous for bioplastics. So these companies are our partners. So we've been working together for many years. And also we work with Hyosok, a Korean company, for carbon fibers. And Shomarat is a French company. Now, for very important application of composite, as you know, is a wind turbine blade. Aeris is the one Brazilian company. We've been working for many years as well, especially for the recyclable wind turbine blade. For the aerospace applications, we've been working with the DSO, Airbus, and Embraer. And for the oil and gas application, which is related to a pipeline, we've been working with Petrobras. And Technip FMC is the one French company, very famous in field of the flexible riser and TCP. And also in Korea, we are trying to develop hydrogen pipeline onshore and offshore, and then oil and gas. And one of the companies is the LS Cable, which is the also very famous in wiring and offshore. And Ajistan is an Indian company who just started developing hydrogen tank in India. And 3P.com, as I said, is a startup company and working with the develop hydrogen tank. And we've been working with the Hyundai for many years. Even now, we develop a hydrogen tank together with them. So this is the covers all our research area, and then together with the global companies. Now, briefly speaking, I would like to introduce our lab. Again, our lab is called HSCL. We have 2 different types of machine equipment. One is the manufacturing facility. Manufacturing means that we have a winding machine, we have an infusion, we have many facility to produce the composite parts. And second category of our equipment is the material test. This shows the vertical machine. We have about 11 vertical machines so that we can keep testing continuously the composite materials. And it's also very important to have design tools, simulation. So of course, when we develop hydrogen tank, we go through all the design procedures of a hydrogen tank. But at the same time, we do have a micromechanical models. Using that, we can analyze the fiber and resin and interaction, which is very important to predict the vertical life of the composite structures, including pressure vessel and pipeline as well. And cost analysis composite is also important because when we as engineers, when develop the technology, but at the end we like to commercialize. If we don't consider the cost at the very beginning, we often to fail commercialize. So at the very beginning, we like to consider the technology together with the cost. So anyhow, again, our vision is that we like to move toward we like to contribute to moving toward the hydrogen society. So in this supply chain, we have a hydrogen production, and second is the hydrogen distribution, like a pipeline, and then we need a hydrogen storage. These three areas is very most important in terms of a hydrogen society. So again, as I said, we are working on the hydrogen distribution, which is the pipeline most likely, and then we also developing hydrogen storage. Well, this is the briefly introduce how we develop a Type 4 hydrogen pressure vessel. And of course, we need to design both and the liner all together, together with the tank design, and considering fiber and resin property, and sometimes the wet winding, sometimes the toe-preg winding. And today I'd like to emphasize the thermoplastic tape winding using the robot system. So anyhow, we do all these steps to develop. At the end, we like to focus on the certification. Eventually, we need to have a certification to commercialize the tank. Well, this series of equipment shows our winding procedures in HSCL and 3P.com. Actually, we are in the same space, HSCL and 3P.com. And as you can see here, we have a tensioner. Especially we need sometimes we need a UV curing and in situ heater and then winding, and we got the final product. We have several different types of tank, but in general, whenever we develop the tank, we always use online camera system, 9 of them, and monitoring what we do, and then any kind of a mistake, any kind of procedures will be well recorded. Some of them are in YouTube. Okay, one of a very interesting tank which I like to share is the to use the steel wire hybrid Type 4 700. This is the we recently developed, and then we pass successfully meet the burst requirements. And as you can see that instead of a full carbon fiber, we use the steel wire. Diameter of each one is the 0.12 millimeter, 120 millimeter. And to do so, the tension is very important. We develop our own tensioner. This is just the one introduction of our activity. And so as you can see that this is the steel wire. Not 100% steel wire. It is the combination of a carbon fiber and steel wire, mostly 50-50 ratio. The main purpose of this one is the fully recyclable, not just the resin, but also fibers. And we also like to reduce the cost. So total cost will be 20 or 30% less than a full carbon fiber. well, this is a little bit heavier than carbon fibers. So this is usually for the lifter or stationary purpose. Another one is that toe-preg hydrogen tank. Use the wet winding, but sometimes we use the toe-preg. As you can see, we hit the overall procedures. This is not our main topic, but I just like to emphasize that our activity or development is not just the wet winding, but also toe-preg and many different types of fibers and resin systems. Okay, well, now, hydrogen-powered transportation is expected significantly grow. This is just a background. But today's hydrogen storage tank has faced some challenges. What is that? Well, current hydrogen tanks are simply too costly to be sustainable. Well, not just because of a tank, but also a fuel cell and all system is simply too expensive. But we are focusing to a hydrogen tank, and we are trying to develop technology how to reduce the cost. That is our main goal. And another one is this hydrogen tank. Since they are made of the regular epoxy, non-recyclable epoxy, simply the tank is not recyclable. So these are two main issues we like to overcome. And I'd just like to review the thermoset epoxy-based wet winding procedure. Here is the liner. And when we develop the liner, we can simulate and how the resin can flow. And simply we, based on the design, we wet wind using the very heavy, fully equipped winding machines. And then, of course, we need to finally cure them in our oven at least 8 hours using the big oven heaters. So what I'm trying to say is the whole procedure is very costly, not only because of a carbon fiber, but whole procedure is very costly. Non-recyclable and very costly. This is the main issue. Well, right now we are trying to develop hydrogen tank, but sooner or later we will face these two main problems. So we are trying to prepare ahead these two main issues. And also liner is a big issue. Liner, as you can see, that blow molding or rotor molding or injection mold, three methods can be used depending on the size and depending on the quantities. We cannot say which one is the best, better than the others, but again, it's depending on the size. So this is a very typical liner blow molding procedures. And as just showed, this can be simulated as well. But we cannot use this blow molding for a larger tank for truck size. So it causes some problem, and especially this liner can be easily detached from the composites. This is one of the main issues we have to overcome since Type 4 has the plastic liner and composites. Okay, in our research, we consider many different types of fibers, and even for the carbon fiber, we use the T700 and also Hyosung and other many fibers, and also resin, regular epoxy, and Arkema Ilium is very interesting resin. It's a thermoplastic but liquid, so we can use the wet winding. And Swanco and Adita Bora, as I said, their product is a epoxy but recyclable. They recently developed and a very important resin system. And also PS6 and PPS or PA11 or PA45 for thermoplastic resin. And winding type can be wet winding and dry and toe brake and thermoplastic toe brake or thermoplastic tape. And then winding machine can be just regular 4th axis or 5th axis, 5 axis, but we mainly develop the robot winding using the automatic tape layering system. So this is a possible storage tank we can develop. We have developed, and as you can see, depending on the resin system, these are 3 groups are non-recyclable, and the other 3 is the recyclable. As you can see, resin are depending on the resin. And fiber can be just a carbon fiber, but different types of fibers and carbon fiber can be hybridized to lower the further the cost. And the winding type is mostly wet, but wet we can choose either just regular toe or a toe brake can be selectable. And capacity can be from 50 to 350. So depend. And the liner is very important, just using the regular liner, but also we can develop the modular liner. So as a result, as you can see, in terms of a mass index and cost index, depending on the combination of the technology, you can see that mass can be reduced and cost also can be reduced. So right now, I like to emphasize the last recyclable thermoplastic tape using the robots. Here is the new technology, new paradigm of a game changing in hydrogen tank is a recyclable thermoplastic tape and recyclable epoxy. So cost effective and hybrid fibers and liners and robot assisted tape winding. Basically, this is how we make modular liners, and then this modular liner will be applied to a robot winding system. Now, robot itself, we call a digital twin robot, means that hardware can be exactly simulated using the software. So as you can see that whatever we simulate can be exactly the wind over the tank. So this is the actually in general it's called automatic tape layering. So this is a tape thermoplastic and this is a laser system, and we just hit and then wind and press and that's done. No more curing system is needed. As you can see that this is a liner, and this is, as you can see, the tape is a thermoplastic and apply a laser system. So laser will melt and press and then bond it permanently. So so we do this one and then we check all the temperature history during the winding. And this using this methodology, we recently complete 52 liter. That is the same size as the Nexo Hyundai. Right. As you can see that it's a fully automatic by the robot systems. And hook winding and the helical winding and all angles is controlled by the robot. One of the most advanced technologies that we have to control all the paths. Layer to layer, the tank gets larger and larger, and we also control the thickening effect. And then we also have a burst test in our lab. As you can see that whenever we develop hydrogen tank, this is a chamber we develop, and then we put it there. This is a tank, inside the chamber, and we have a camera there. So put it there, and we apply the pressure 1,500, 1,600, and then apply and then inside it burst. It burst at 1,500 or 600. So in our center, we design and we manufacture, we do a burst test. So we cover all the whole procedures to optimize that. And then also, as I said, we like to reduce the cost. And then we like to develop a futuristic tank. In this case, is the thermoplastic. Okay, so this is a conventional, as I mentioned, and now robot ATL assist thermoplastic. You just have a liner, and then robot winding is done. No more curing procedures are needed. So it can be, the cost will be reduced by hybridized carbon fiber and also very reduced steps of manufacturing procedures, and this is the recyclable. So again, we try to achieve these two goals. Okay. Second category I'd like to emphasize is that hydrogen pipeline, onshore, offshore, and especially this is the risers. So this is the riser. It's a 3,000 meter deep. It's okay. Mostly, deeply in the 3,000 deep, and depending on the depths, this will be a very high pressure, and this is a high tension. So we, for example, we have three different design. We connect them together. Each section has a different design because again, this is high pressure, high bending, and this is a high tension, etc. So basically, we've been working on this area for the last 10 years, and we developed the program called High Flex. This High Flex can be applied to not only bonded pipe, but also unbonded TCP. TCP means the thermoplastic composite pipe. So this is all loading condition and specification. And with this tool, we can design. And in terms of a load, we consider, first we consider static load. Inside pressure, outside pressure, and tension is a static. Bending is also very important. And creep and fatigue. These are all the load can be considered, or should be bending radius is the one we have to consider. Because the reason why we have to consider is the bending is the pipe has to be spoolable for transportation. This is the more important than just internal pressure. Okay, well, flexible riser. Now, how do we make this flexible riser? As I show you the robots and laser, this system can be applied to manufacturing of the flexible riser. It's very similar, and the only difference is that this pipe is continuously moving forward, and then outside the laser heated thermoplastic tape wounded over the pipe. That's the difference. And for application to a flexible riser, we often use big tracks, PEEK and AS4. Or, AS4 is the very high-end carbon fiber. So we have characterized all these metrics and carbon fiber and put into design tools, and we are able to design TCP flexible riser. And this is also our lab. We are only difference is that in our case this robot is moving because continuous pipe takes a long space. We just rotate. Robot arm is moving back and forth. That's the only difference. So using this technology, we again develop how we heat it up using the laser, and also a continuous, applied to a continuous. Again, this is the collaboration with the industry. With this technology, with 3P.com, we developed all the design tools. And then together with a pipe machinery company, such as the Van Nuys, such as the Goldstone. And then this design tool can help customer. Customer means that they produce the pipeline. So using their machine, but also using our design tool, and can develop or produce the many different types of pipeline. Okay, well currently, again, 3P.com is a startup company, not the academic side, but we've been working together, actually same members. Actually, we have our member there, and there, and these three gentlemen and ladies are here. So resin supply, we work with thermoplastic, Cathay, bioplastic, #1 company in China, and also Gamma and Itabora and things. Yes. And 3P.com working together, and then our customer is Hyundai, and India company, and Taiwan, and then Brazil, and so on. So our vision is that we develop the recyclable and cost-effective hydrogen tank. Today I just showed the thermoplastic, but regularly we use the wet winding, epoxy, and develop. And also by 2030, we would like to lead the market of the sustainable hydrogen storage tank. Okay, thank you so much.